Carbon is a fantastically important element. There are probably far more molecules that contain carbon than any other element. The reason why you can get so many carbon compounds is that carbon atoms form chains very, very easily, sometimes millions of atoms long. If you just have atoms that will form one or two bonds, then you can't build up huge numbers of molecules. But if there's no limit to the number of bonds you can make things that are really long. It's like the difference between a lorry, a truck, which can pull, if you're lucky, one trailer or perhaps two, and a train where you can put as many wagons or carriages as you want. So you can go a really long train. So it's just the same with carbon.
So carbon, it's around us everywhere. We're all carbon. There's lots of carbon in us, in all the hydrocarbons within our body, lots of the structures inside us, and many of the materials that we use every day. In fact, a majority of us use carbon in the form of fuels every day to get to work or to go home.
Without carbon, we couldn't exist. You're carbon, I'm carbon. We have bones made out of calcium. But the important parts, our brains, contain largely carbon. They contain nitrogen and oxygen and hydrogen as well, but carbon's the key. Carbon is one of the very few elements that has given rise to a whole area of chemistry. Organic chemistry, the chemistry of carbon compounds, is almost a separate discipline from some other areas of chemistry. And most of the molecules that we use for plastics, for pharmaceutical products, for our food, are all carbon compounds.
Carbon's an extremely common element, but it comes in a number of different allotropes, so different forms. And this one here, this is actually some charcoal, which is just simple carbons, very similar in very in fashion to graphite.
You can find lumps of carbon lying around. This is a piece here that I found on the beach on the northeast of England. It's a piece of coal. It's not absolutely pure carbon, but it is a very high proportion of carbon, and compared to other stones of this sort of size, it's really quite light. More recently, people have discovered diamonds, and of course graphite, which is the black material that you get in pencils. People call them lead pencils, but they actually contain a form of carbon called graphite.
So carbon comes as graphite, as diamond, and also as buckyballs or fullerenes. So the carbon here, which is a bit like the graphite, is very amorphous, and it's very free flowing. So we're going to pour a little bit of the carbon out onto the paper so that you can see. So you can see it's a very light powder, and you can see that it's a very nice, easily maneuverable and easily workable material.
The thing that's really exciting is that in the last 20 years, people have discovered new forms of carbon. Now, this is extraordinary. People have known of carbon for thousands of years, even longer. And suddenly, in the last 20 years, the number of different types of carbon has grown enormously. I have a colleague who's a specialist in these new forms of carbon, and I went and asked him for a model, and he gave me a whole suitcase of models. Let me show you. So, what have we got? First of all, this is a model of graphite, the materials that's in the middle of pencils. And it consists of layers of rings, of hexagonal rings of carbon atoms. That's 6 carbon atoms, and they're joined together in layers. Can you see here there are these purple bonds in between them? You can see they're not very strong. One's even broken here. Very recently, in the last 10 years, it's been discovered that using a piece of sellotape, you can pull off these layers and make single sheets of these carbon atoms. It's called graphene. The 2010 Nobel Prize for Physics was given to 2 scientists for discovering graphene. There's this structure here where each carbon atom is joined to 4 others in this sort of tetrahedral pattern. Tetrahedron is this group, one in the middle with 4 round it. And this is diamond. It's really very strong. Whichever way you squash it, it's strong. You can't peel off layers of diamond with a piece of sellotape. Diamonds are colourless, and to understand why, you have to understand what gives rise to colour. And the colour of anything, mai tai, anything, are caused by electrons in the molecules or material, and they absorb energy and go from one level to another. In diamond, there are bonds between all the carbon atoms that use all the electrons. The electrons are very tightly bound, and none of them can change their energy state, so you get no absorption, at least in the visible region of the spectrum. On the other hand, with graphite, the electrons are less strongly bound. In fact, it conducts electricity, and it's black because the electrons will absorb all wavelengths of visible light, right from the blue to the red, so that it looks black because none of the light is reflected from it. Inside here, we have the famous molecule C60, like a football, 60 carbon atoms. Andrei has put a little one inside here, but forget that for a moment. So you can have this molecule, C60, first discovered in the late 1980s and only isolated in the early 1990s. And there is a very similar molecule which looks a bit more squashed, which is C70. Now these are also coloured, but their colour is rather different. Have a look here. I've got 2 samples, one of C60 and one of C70, both of them dissolved up in a solvent, toluene. So if you look here, C70 is a sort of reddish-brown colour, and C60 in this solvent has a beautiful colour. I call it purple, other people call it magenta. Back to the box, and in here we have the final form of carbon, which are called nanotubes. These are whole tubes made up of hexagons. You have 2 sorts, one which is closed at the end, and this one here which is open, rather like a basket. You can put things inside it. The final model is graphene, this material that you can peel off graphite with sellotape, sticky tape. And the reason that people get so excited is, first of all, this is a very thin material. It's only 1 atom thick. And you can react the carbon atoms on here with all sorts of different molecules. You can make very strong materials. You can start making electronics, carbon computers, things like that. And many people believe that graphene is one of the materials of the future. This is one of Andrei's exhibits. He uses it in exhibitions to measure electrical conductivity. You see, if you take a piece of metal like this coin and you put the 2 electrodes on there, you can see it conducts electricity. All the lights light up and the needle goes across. So he's got different samples. This one here is coal and this is graphite. So there's a track of, this is a photo, and this is a track of coal between 2 metal electrodes. And you can see if we put the electrodes on here, the coal doesn't conduct electricity at all. However, if we take the graphite and do the same, it conducts electricity, not very well, but you can see you do get some electricity going through. On his other sheet, he's got a sample of C60 and here of the carbon nanotubes. And you can see the C60 doesn't conduct electricity either. The electrons can't jump between one molecule and the other. But when you come to the carbon nanotubes, which are long, long molecules, they conduct electricity really well. Not quite as well as a metal, but pretty close.